Today I'm going to go over the quadratic formula, which is listed down right here, to solve quadratic equations of the form ax squared plus bx plus c equals 0. And the focus will be on the discriminant b squared minus 4ac that goes inside the square root. And the reason why I have 4 examples is because the discriminant comes in 4 types. Sometimes I call it 4 different flavors. The discriminant b squared minus 4ac, which is, as you could see, goes inside the square root of the quadratic formula, comes in 4 types. If it equals 0, we're going to end up having a square root of 0, which is 0, so there is no need to say plus minus 0. And that will give me one rational solution. If it's positive, but a perfect square, something like 36, as an example, the square root of 36 is 6, so we end up adding and subtracting 6 in the numerator. That will give us 2 rational solutions. In case if it was positive, but not a perfect square, like a prime number, for example 5, the square root of 5 is irrational. That's in decimal form, non-repeating, non-terminating decimal. That will give me 2 irrational solutions. And the last type, if it's negative, less than 0, we're going to end up dealing with the square root of a negative number, which gives me the imaginary number I. That's why we have 4 different types. Let's get started. 2x squared plus 4x minus 30 equals 0. That's the equation that we are given. As you could see on the right side, I have the notes and I have everything ready to go to save some time from recording. That's why I call my videos lecture notes. So b squared minus 4ac, to do it, let's identify a and b and c. A is 2, that's the leading coefficient of x to the second, and b is 4, and c is negative 30. B squared will be 4 squared minus 4 times a, which is 2, times c, which is negative 30. That's a 16, 4 squared, minus 4 times positive 2 times negative 30 will end up positive. 2 negatives in multiplication will give me positive. 240. 240 plus 16 is 256. Now that 256 goes inside the square root on the left, and minus b would be minus 4, the opposite of b, over twice a, and a is 2. Simplifying this, I have minus 4 plus minus square root of 256 is positive 16, because 256 is a perfect square, just like 36 and 49 and 81 and so on. Over twice a, which is 4. Dividing both sides by 4, as you can see it does divide, we could use the distributive property. Plus minus 16 over 4, and that is negative 1 plus minus 16 over 4, which is 4. So I have 2 solutions. Once we take the plus as an option, plus 4, which is a 3. And once we take the option as subtract, 4, which is negative 5. To support that, we have 2 rational solutions, so we are on this case. The discriminant was positive and perfect square, which is 256. 2 rational solutions, 3 and negative 5. Graphically, it doesn't say graph it, but just to show you what we have as notes, 3 and negative 5 are clear numbers on the number line, on the x-axis, just because 256 is positive and perfect square. Number 2. We have 3x to the second minus 12x plus 12 equals 0. So a is 3, b is negative 12, and c is positive 12. b square will be negative 12 square minus 4 times a, and a is 3, and c is positive 12. 144 minus, it's not going to cancel. 4 times 3 times 12 is 144 again. And that is a 0. So that is case number 1. When the discriminant is 0, we have only one answer, and it's rational solution. Going to the left, the discriminant is 0, minus b, which is the opposite of negative 12, over twice a, and a is 3. That's a positive 12 plus minus 0 over 6, which is 12 over 6, and it's only one answer, one real solution, which is 2. To support that graphically, I have the following, and this is usually called double solution, as you could see right here. Double solution, because graphically it bounces off the x-axis. Double, that means it doesn't cross the x-axis graphically, just to support that. So that should do it for number 2. Let's go to the third example, and I have 4 examples. Solving minus 5x to the second minus x plus 21 equals 0. To identify a and b and c, we have a equals negative 5, and b is negative 1, and c is positive 21. b squared minus 4ac will be minus 1 to the second, 4 times a, that's negative 5, times c, which is positive 21. That's a 1, plus, because I have 2 negatives multiplied together, plus 421. 420. Sorry, I'm thinking ahead. The answer is 421. Now 421 is a prime number, it's not a perfect square, and in this case we are ending up with 2 irrational solutions. Let me show you the steps on the left and show you the 2 irrational solutions. So we have the opposite of b, that's a minus 1, plus minus square root of 421, which is not a good looking number. If you apply that square root to 421 on the calculator, it's going to give you irrational, non-repeating, non-terminating decimal over twice a, and that's twice negative 5. The answer is going to be 1, positive 1, plus minus square root of 421 over twice a, which is minus 10. So I have 2 options, either plus or minus. That's a 1 plus 421, and 1 minus square root of 421 over negative 10. The first one is approximate to negative 2.1518, and the second one is approximate to 1.9518. The reason why I went to the decimal form, because I want to show it to you graphically how it looks like. Those are called 2 irrational solutions, because the discriminant is not a perfect square. 421 is a prime number. You could see from the graph that those numbers are not rational, that we could identify clearly on the number line. That should do it. And the graph opens down because negative 5 for a is less than 0. The graph opens down. Last question. Solving x to the second plus 8x plus 18 equals 0. So we have a equals 1 and b equals 8 and c equals positive 18. b squared minus 4ac, that's 8 squared minus 4 times a times c. 8 squared is 64 minus 72, 4 times 1 times 18. This time it's a negative number, negative 8. Negative 8 is a negative number, which means we're going to end up with the last case, and that is two complex solutions because of the imaginary number that's going to show up from the square root of negative 1. Going to the left, applying the numbers to the quadratic formula, we have minus b, the opposite of b, which is 8, plus minus square root of the discriminant, which came up to be negative 8, over twice a, and a is 1. I know a is not clearly stated, but we agree that a is 1 right here. This simplifies to the following: minus 8 plus minus square root of negative 1, and 8 is 4 times 2. If we break it down, 4 and 2. The reason why I did that, because the square root of 4 simplifies to 2, all over 2 times 1, which is 2. That will give me the following: negative 8 plus minus square root of negative 1, which is an I, square root of 4, which is 2, and square root of 2, we leave it because we don't want to write non-repeating, non-terminating decimal, over 2. So as you could see, everything divides by 2. The 8 divides by 2 and the 2 on top divides by 2. Simplifying that will give me negative 4 plus minus I and square root of 2. The two options will be x1 equals minus 4 plus square root of 2 times I, or I times square root of 2, and minus 4 minus I times square root of 2. To support that, those complex solutions don't show up on the graph as crossing the x-axis, as you could see right here. And that is it. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.